Hello, ladies and gentlemen. My name is Ning. I'm a postdoctoral researcher from Sun Yat-sen University. My presentation is multi-scale attention-guided indoor localization using geomagnetic sequences. This is the outline of my presentation. Indoor localization has a wide range of compelling applications. To achieve accuracy, researchers have studied various techniques for indoor localization. Of all these techniques, geomagnetism has attracted much attention lately, mainly because it is pervasive, relatively stable, and efficient to collect. Many approaches leverage shape comparison algorithms, such as dynamic time warping, to compare two geomagnetic sequences. Despite the accuracy, it has a few limitations. First, the dynamic time warping is usually computational cost with long sequences. Secondly, it pays more attention to global geometrical features, and thus discarding local anomalies, leading to degraded accuracy. Secondly, with all various scales anomalies, it is difficult to fuse them effectively. To address above problems, we propose MAIL. Our key novelties are as follows. We propose an efficient geomagnetic localization network. We propose a scale-based feature extraction unit to extract scale-based features. And we also propose an attention-guided fusion and localization scheme. We briefly review our related work as follows. Recent arts are broadly divided into the following two categories: discrete fingerprint-based geomagnetic localization and sequence-based geomagnetic localization. While the second category enhances the localization accuracy using temporal correlations, it has a few limitations. First, the computational cost is relatively high with long sequences. Secondly, it tends to discard local anomalies, leading to compromised accuracy. Next, we elaborate our multi-scale localization network. Our network consists of three major components: a scale-based feature extraction unit, an adaptive attention generation unit, and a location estimation unit. We design a scale-based feature extraction unit where we divide the geomagnetic magnetic sequence into a few subsequences. Using the gated recurrent unit, we extract a feature vector for each subsequence. By feature concatenation, we get a scale-based feature phi m for current scale m. Then we normalize it and get a normalized scale-based feature cm. Due to the diversity of geomagnetic anomalies, we propose an adaptive attention generation unit, where we grasp a attention value for each scale using the gradient sequence tau and the p-ReLU function. Combined with multi-scale feature vectors f and their attention values w, we fuse them attentively and get a fused feature vector f. Then we use the linear regression to estimate the user location x hat. In our training stage, we use the Euclidean distance as our loss function. In order to evaluate the performance of the proposed approach, we have conducted extensive experiments in three different trial sites. The commutative density function of the localization error demonstrates that our approach improves the localization accuracy by a large margin compared with state-of-the-art competing scheme, mainly because our multi-scale fine-grained location feature extraction and attention guidance. We also evaluate several major important parameters on the main localization error. We repeat our experiments with and without attention guidance and compare the localization error. The results show that our localization error is lower with attention guidance. To summarize, We propose an efficient sequence-based geomagnetic localization network. We propose a skill-based feature extract unit to extract multi-skill features. Thirdly, we propose an attention guidance, where we fuse the multi-skill features attentively and estimate our current location. In the future, we plan to study crowdsourcing for efficient geomagnetic database construction and update. We also plan to study efficient deployment in mobile devices. This is the end of my presentation. Thank you.